We are moving on to day 2 of partial fraction decomposition. To do a quick recap of what we did last class, we talked about 2 cases. So if you're watching this video, you need to watch the previous video that is on the Learning Hub already. That 2 cases that we covered last class were when we factored out the denominator and we got linear factors. There was 2 cases with that. One in which each factor was completely different, and the other one where maybe one of the factors repeated. I said that for this class you're not going to get something that repeats more than once. Right? So twice. So it's just going to show up 2 times, right? It can repeat 3, 4, 5 times, but just 2 times I think it's good enough for what I need for this class. So what we're going to move on to today is that we are going to talk about what if you get a quadratic factor. Okay? So that's our first example of the day. So we're going to talk about quadratic. So we'll begin with a problem that looks like this. X minus 3 divided by x to the 3rd power plus 3x. Okay? Now, I know that I've been calling all these different scenarios case 1, case 2, case, etc., right? There's an unlimited amount of cases if you want to call them a case, because you can have quadratic factors, and then you can have quadratic factors that repeat, and then you can have cubic factors that repeat, and so on forever. In true reality, the process for all of this are the exact same thing, with the exception of one thing for each one of them, which I'm about to show you with this problem. Okay? The first step when we're doing this was to factor out the denominator. That's still your first step. It doesn't change. If you factor out the denominator, you get x times x squared plus 3. Agreed? Okay. When I look at that x squared plus 3, it is factorable. But the only way that I can factor that out would be to use imaginary numbers. Agreed? We are not bringing imaginary numbers into this. This is completely real, right? There's no imaginaries here. So that means that if this cannot factor out with a real number, we are not going to do it. Understood? Do you guys now see how I have a linear factor and now I have a quadratic factor? Giving me 2 factors, letting me know that I have 2 fractions. One fraction in which the denominator is x, and another fraction in which the denominator is x squared plus 3. Okay? Now, forget this one with the x squared plus 3 for the moment. The second step, is exactly the same as the first case that we talked about last class. There needs to be something on top, right? And we just kept using letters in alphabetical order. So I am just going to say that a over x. Agreed? Here is where the change comes. After this, everything will be the same. Okay? We're no longer dealing with something that's linear. It wasn't a linear factor. This is the simplest it can get, right? A quadratic. Because the simplest form of that is a quadratic, things look a little different. I'm going to give you an explanation of the why. You may not understand it, but I still just want to make sure that you understand why this happens. Okay? We're about to, when we finish this unit, we're going to move on to the last topic of the year, which is known as limits. Okay? Limits is the foundation of calculus. Without limits, nothing in calculus exists. Okay? Now, right after we talk about limits, the first topic that you will cover with me next year is known as derivatives. Okay? Some of you guys might have already seen them. Some of you guys, this probably is the first time you hear the word. Okay? So I'm not going to talk about specifically what it does, but how it works. When you take a derivative, because a derivative it's a process that you do, I want to talk about this fraction right here. Do you notice how this is linear? When you take the derivative of something that's linear, your answer is just a constant. And that's the reason why I put just a. A is just a constant. But when you take the derivative of something that is a quadratic, your response is a linear. So x to the first power. So that should give you a hint that on the numerator you're going to have x to the first power somehow. So x. Well, how do you know that there's not a number in front of x? You don't, so you need to account for that. So how do you think I'm going to account for that? B. That would be linear, right? However, can a linear also include a constant? So how do you know that you don't have a constant? You don't, so you have to account for that by saying plus some kind of constant. Okay? Now, that is as far as we're going to take it in this class. But technically, just to make sure that you comprehend what we're talking about here, if this was a cubic power, when you take a derivative of a cubic, the derivative would be a quadratic. And then in that case, if it was quadratic, let me go to a separate sheet of paper. So let's say this was x to the third plus 3. Like I said, the derivative would be a quadratic, which means that you would have to have some form of x squared. Again, you don't know if there's a number in front of it, so let's just say that it has a number in front of it. But a quadratic could also have an x to the first power. And a quadratic can also have a constant. Do you guys get where I'm going with this? Every time it's going to be one lower, and you've got to account for every single power until you get to a constant. Okay? But for this class, we're only going to talk about quadratic. That's as high as we're going to go. Any questions? That's the only difference. The rest of the process, the exact same thing. Okay? I have two fractions. I need to add them. What do I need to do? Get common denominators. But you already have the common denominator, right? It's up here. So how can I get this first fraction to achieve this denominator? So multiply a times x squared plus 3. Agreed? And how can I get this second fraction to achieve this one? Multiply the entire numerator. So notice how I'm going to put parentheses over the entire numerator times what? X. That would be the numerator of your brand new fraction, right? Remember how on day one I say we don't really need the denominator because we've already got it to match? I'm not going to write it because I'm lazy. This is the numerator, right? What does this numerator need to be equal to? The numerator of what was given to me, right? X minus 3. And so far, everything has been the same with the exception of just what we put above the second fraction. Agreed? Once we got here, what did you do? You simplified. You could simplify. You could multiply everything out. That's one way of doing things. And if you do decide to simplify, then you would have to have a system of equations, right? The second method, which I encourage you to try, is to try to choose values of x that would zero out terms. In other words, the shortcut for that is look at your common denominator that you have here and set them equal to 0. X equals 0 would be a good value for us to try. So I'm going to try x equals 0. Okay? So what that means is that I'm going to plug in 0 for every x here. A times 0 squared plus 3 plus b times 0 plus c times 0 equals to 0 minus 3, which is negative 3. Agreed? Okay. When I look at this expression, this times 0 is 0. So the negative 3 drops there. 0 squared is 0 plus 3 is 3. 3 times a is 3a, which means that 3a plus 0 equals to negative 3. Therefore, a is equal to what? Negative 1. Agreed? So I have one of my values, so I'm going to either highlight or underline and do something so I don't lose it. Okay? Now, I'm going to go back and look at this expression that I have here. So I've already tried 0 so that I could cancel this out. Is there any value I can plug in here for x that would make this 0? What was that? It would have to have an I, right? And we don't want an I here. So unfortunately there isn't. We are done with all the x values that are going to cancel things out for us. So what I need to do is, I'm going to actually, this helped us out. I'm going to rewrite my expression. Instead of having this expression where I have a times all that mess, now I know that a is negative 1. So I'm going to rewrite my expression as negative 1 times x squared plus 3 plus bx plus c times x equals to x minus 3. Now we went from having 3 unknowns to just 2. And now we have no other option. We have to rely on system of equations. Okay? You can plug in any value that you desire. Make it easier for yourselves. Pick values that would keep the numbers low. What would be a good x value to try? Let's go with 1. 2 is also a good one, but 1 is better than 2 because it's even smaller, right? So here we go. 1 squared is 1, plus 3 is 4, times negative 1, negative 4, plus. Alright, so here's where I want to make sure that I don't lose anyone. So this is just the 1, right? Which just makes it b plus c. Agreed? And this is just a 1. So b plus c times 1 is b plus c. So b plus c. And 1 minus 3 is negative 2. I want to get the variables by itself, so I have to get rid of this negative 4 by adding. So b plus c equals to 2. I'm going to put a star, underline, or something so that I don't lose this. I need this. I need to come up with another expression that has b and c so that I can use a system of equations. And what's the only way that I can find another or a different equation that's going to have b and c? Try another x value. Doesn't matter what you want to try. What do you guys want to do? Negative 1? Okay. So if I try negative 1, let me look at my expression again. So here's my expression. So it's going to be negative 1 times negative 1 squared plus 3 plus b times negative 1 plus c times negative 1 equals negative 1 minus 3, which is negative 4. Right? Okay. Go ahead and get rid of this paper. We just got to simplify now. Right? Okay. Negative 1 squared is 1 plus 3 is 4 times negative 1, negative 4. This becomes negative b plus c times negative 1. What would that do? Just switch the signs, right? So plus b minus c equals to negative 4. If I get b and c by itself on one side, I get that b minus c is equal to what? 0. I have one equation in terms of b and c, and according to our previous work, we also had b plus c equaling 2. At this point, we need a system of equations. Right? Several ways to solve this. I am going to leave that up to you. Whether you want to use substitution, whether you want to do addition, whether you want to use a matrix, that's going to be totally up to you. Okay? I'm going to use addition for this one. Are we okay with that? So I have b minus c equals to 0. B plus c equals to 2. So if I add these expressions, b plus b is 2b. Negative c plus c is 0. And 0 plus 2 is 2. Which means that b is equal to 1. And according to this expression, if b minus c equals to 0 and b is 1, 1 minus what would be 0? So b and c are 1. And according to my previous paper, so that I don't forget, a was negative 1, right? So a is negative 1. What is our final solution for this? Well, I'm going to go back to, I had already broken it up on my previous page to be this, right? All I have to do is substitute. So a for us was negative 1. Negative 1 over x. B and c for us were 1. So therefore this becomes plus x plus 1 over x squared plus 3. And we're done. Yes, sir?
Back when we were finding out B and C,
Uh-huh.
you didn't necessarily have to go into the systems of the equation, because if you saw that B minus C is equal to 0, they have to
Correct.
be equal numbers.
So you could have reasoned that one out. Absolutely. If b plus c equals to 2 and b minus c equals to 0, you can reason out that it has to be 1. So you wouldn't have to show me work for that. Cool? All right. Any questions about quadratic factors? We're good? So I want you to try this one on your own. If you're watching the video, please pause as needed. 3x squared minus 2x plus 2 over x minus 2 times x squared plus 1. Okay? I want you to try this one on your own, but I want to make sure that at least I can get all of you started with your assistance. Okay? So I don't want to tell you what to do. Okay? So at least write down the problem, and then if anyone wants to volunteer and tell me what to do first so that we can all get started as a class, that will be greatly appreciated. All right, anyone? What should I do first? What was that? But shouldn't I factor first? Well, it's already done for you, right? So I know that previously in the video I said factor first, but hey, this one's already factored for you and it's not going to go any further. So split it up into how many fractions? 2. Why? Because you have how many factors? 2. So this is going to split up into 2 factors in the form of what over what plus what over what. So in the first one, what do you want to do? A over x minus 2. Why is it only A? It's a linear, okay? And the next one will be what? Bx plus c over what? Why does it have to have a linear factor on the numerator? Because the bottom is a quadratic, but there's one more rule. It's not only a quadratic, but it's a quadratic that does not reduce any further. Okay? Because you could have something that's quadratic, but if it reduces even further, then you wouldn't put bx plus c. Okay? I'll explain further what I mean on that here in just a second. But from here, you should be able to finish up this problem. So if you're watching the video, pause. Alright, so here's the final answer, guys. Let me kind of scroll back up here so that you can see all of my work, and I'll go slowly. Okay? Go ahead and pause the video if you're watching it and check your work, and here in just a minute I'll move the paper up a little bit more. I'm going to move up the paper a little, and there is the end. Every problem that we have done so far on this lesson has dealt with a proper fraction. What does that mean? So give me an example using numbers of a proper fraction. 1 over 2, 3 over 4, 2 over 3. Those are all proper. Let me give you an example of an improper fraction. 5 over 4, 3 over 2, 7 over 6. So what does that mean? The numerator is going to be bigger than the denominator. Everything we've done up to this point, the denominator has been bigger. But when it's not, here's what we do. Alright, I promise you, this is the last example we're doing. Okay? You guys have really hung in there. I'm going to be honest, like, this is a lot of information. Okay? Last problem. Here we go. I've actually, I know you're gonna hate me even more for this, and I'm okay with it though. I can leave. I can sleep at night. I found a good problem that's gonna help us review a lot of things that we've done in the past. I'm just trying to get you ready for that final exam, just so that you don't forget things. Okay? Here we go. Here's our problem. X to the fourth power divided by x minus 1 to the third power. Do we all comprehend why this is improper? Right? This is an x to the fourth to an x to the third. Which means that all the previous problems that we've done, we can't start doing all those steps until we can make this proper. Okay? We have to. So let me give you an example just with numbers. If you had 7 over 6, that's the same thing as saying 7 divided by 6. So you would divide and you would say 1 with a remainder of 1, 6. So you have 1 and 1, 6. Right? It's 1 and 1, 6. I divided. I'm going to have to use division here to make this a proper fraction. Okay? Now, why did I choose this problem? It's because in order for me to divide this out, I'm going to have to expand the denominator. Agree? Which means that I'm going to have to multiply x minus 1 times x minus 1 times x minus 1. Now, you're more than capable of doing that. I'm sure you are. But I showed you a faster way of expanding a binomial in this class. All right, so quick refresher here of expanding binomials. This will be on your final, so you're welcome. Expanding a binomial. Does anyone remember what the first step is? We need the triangle eventually, not yet. This is a power of 3. How many terms? 4. Okay, the first term is going to be x to the third times negative 1 to the 0. You guys remember that? Plus, the second term is going to be what? X to the second times negative 1 to the first. Plus, the third one is going to be x to the first negative 1 squared. And the last one is going to be x to the 0 negative 1 to the third. Is this coming back to you a little bit? It's descending in order and then ascending in order, right? I always put a plus sign after every term. Are we okay with that? Now, I want to clarify, I don't want you to panic. This is not going to be on this test at all. I'm just trying to review some material with you, that's all. Okay? How do I find, because if you recall, there's supposed to be a number in front of all this. I had two choices. One of them was already mentioned, was the Pascal's triangle. Does anyone remember what the other option was? Combinations. Okay? We're going to use the Pascal's triangle just to speed the process, right? So I'm going to come up with a very quick Pascal's triangle. So it's going to be 1, 1, 1. 1, 2, 1, right? 1, 3, 3, 1. Well, according to this thing, I need 1, 2, 3, 4 numbers. This one has 4 numbers, so I'm going to stop. 1, 3, 3, and 1. We're good? What did you do after that? Just simplify the expression, right? So what's negative 1 to the 0? 1 times x to the third. So it's x to the third. Negative 1 to the first times 3. So minus 3x squared. Negative 1 squared is times 3. So 3x. Negative 1 to the third times 1. Oh, look at that. We're done. It expanded out for us. Cool? Sweet. Now, why did I try to expand this out? Let's not forget what our goal was here. Because I need to divide. Another good refresher for our final. What divided by what? X to the fourth divided by x to the third minus 3x squared plus 3x minus 1. Agreed? And I'm going to run out of room, so I'm going to go ahead and move on to a separate paper now. Okay. I remember telling you in class that with long division, it's not necessary for you to put 0x to the third, 0x squared, etc., etc. But you are welcome to do it if you need to. So if you want to fill out the rest of this, you can put 0x cubed, 0x squared, 0x, and then 0. Okay? How does long division work? We're going to look at this value. What is going to make this value match x to the fourth? That's what goes up here on the quotient. Now what? Multiply it out by everything, right? So x to the fourth minus 3x cubed plus 3x squared minus x, right? What did you do, or what do you do after you multiply? Subtract. Use parentheses so that you don't make a silly mistake. X to the fourth minus x to the fourth goes away. How many x cubes did I have? 0. 0 minus negative 3x cubed is positive 3x cubed. How many x squares? 0. 0 minus 3x squared is negative 3x squared. 0x minus negative x is positive x. And technically, if you want to drop a 0, you're welcome to drop a 0. What's that? Someone's watching something. Just put it on mute. Good? All right. Now what? I can keep going. So I can multiply this by 3 so it matches that. Agreed? So plus 3. 3 times x cubed is 3x cubed. 3 times negative 3x squared, negative 9x squared. 3 times 3x is positive 9x, and 3 times negative 1 is minus 3. I have to subtract. Agreed? This goes away. What's negative 3x squared minus negative 9x squared? Positive 6x squared. Positive x minus 9x. Negative 8x. And 0 minus negative 3 is positive 3. Agreed? Can you multiply this by anything to get 6x squared? No. What did you have to do with your remainder? So your answer would be x plus 3 plus what? 6x squared minus 8x plus 3 divided by what? X cubed minus 3x minus 1. Agreed? Yes? All right. We reviewed binomial expansion. We reviewed division. Here's where we're at. Do you guys agree that this statement is the same thing as this statement? Yes, they are. How did division help us? We made it proper. Look, now it's third power and second power. All that work so that now I can finally use partial fraction decomposition. Okay? First step of partial fraction decomposition is what? Factor out the denominator. Okay. Do not use rational zero test because that's what you would have to do now. It's not going to factor by grouping. But why are you going to do all that work? Wasn't this already given to you from the beginning, factored out? If you want extra work, do the rational zero test. But you already know that this entire thing is equal to x, what was it, minus 1 or plus 1? Minus 1 to the third. It is already factored out for you, so don't waste your time trying to factor it out. Okay? Now, remember, I'm going to put a star here because I'm not going to worry about this x plus 3 for the moment because I don't need to. What is the only thing that I need to decompose? The fraction. But this has to be part of your answer. So I like to put a star so I don't forget it. Okay? Okay. Let's work on this. Partial fraction decomp on this one. How many fractions? 3. 1, 2, 3. What's under the first fraction? X minus 1. What's under the second one? X minus 1 squared. And what's under the third one? X minus 1 cubed. This is linear, right? So, A. This is quadratic, but it factors out to be linear, so just B, right? This is cubic, but it factors out to be linear times linear times linear, which is just then C, right? Okay, what's the common denominator? X minus 1 to the third power. How can I achieve that on this first fraction? So A times x minus 1 squared plus, how can I achieve it on the second one? B times x minus 1, how can I achieve it on the third one? It already has it, right? So plus C. What does this have to be equal to? Your numerator, which is 6x squared minus 8x plus 3. Yes? Alright. We only have one option that would cancel things out for us. That would be 1. So when x equals 1, 1 minus 1 is 0, that goes to 0. 1 minus 1 is 0, this goes to 0. C equals to what? Well, that's 6 minus 8 is negative 2 plus 3. C is 1. Alright, so now I have the following. A times x, B times x minus 1 plus 1 equals 6x squared minus 8x plus 3. Can you think of any other x value that are going to cancel things out for us? No, right, because that was it. It was 1. So what do you suggest I try? Let's try, always start with 0. 0. Okay? If I plug in 0, 0 minus 1 is negative 1. Negative 1 squared is 1 times A is A. 0 minus 1 is negative 1 times B is negative B. Plus 1 equals 0 squared is 0 times 6 is 0. Negative 8 times 0 is 0. So plus 3 is 3. So what's A minus B? 2. Now what am I going to have to do? Find another one. This would be a great bonus question. What would be a good x value to try? Negative 1. Negative 1. Alright. Negative 1 minus 1 is negative 2. Negative 2 squared is 4, and 4 times A is 4A. Negative 1 minus 1 is negative 2, times B is negative 2B, plus 1 equals, alright, negative 1 squared is 1, times 6 is 6. Negative 8 times negative 1 is, so plus 6, 14, plus 3, 17. 4A minus 2B would be equal to 16, and I can make this easier by dividing by 2. So 2A minus B equals 8. So I have this equation, and this equation right here, what can I do with them? System of equations, right? We can either subtract or, yeah, we have to subtract this ones, right? Yeah. So a minus b equals to 2 minus 2a minus b equals to 8. A minus 2a would be negative a. Negative b minus a negative b cancels away. And 2 minus 8 is negative 6. Therefore, a is equal to 6. If a is 6, and you know that a minus b equals to 2, that means that 6 minus b equals to 2, which means that b is equal to 4. And just so that we don't forget, what was c for us? And that's all we had, right? So what is our final answer? 6 over plus 4 over x minus 1 squared plus 1 over x minus 1 cubed. Is that it? Do not forget, remember I put a star? What am I forgetting? What else do I need? X plus 3 plus all these fractions will be the partial fraction decomposition of this problem. We good? Congratulations, you have finished partial fraction decomposition. Yes, ma'am.